Hey everybody, thanks for tuning into Module 5 on intervals, segments, and complexes, part of our EKG Fundamentals series. Learning objectives for this module, we're going to be able to analyze the various intervals, segments, and complexes, mostly just the important ones, in the EKG strip, and determine whether they are normal or abnormal. Before we dive into it, I do want to review what the boxes in the EKG paper represent. Do remember that you have big boxes and little boxes. Each big box contains 5 little boxes going up and 5 little boxes going horizontally. When you do look at it horizontally, each big box represents 0.2 seconds of time, and each tiny box therefore represents 0.04 seconds of time. Okay, so let's talk about the intervals, segments, and complexes. The first one is the PR interval. The PR interval contains everything from the beginning of the P wave to the beginning of the QRS complex. So I know the naming kind of makes it confusing because it does contain an R, but the PR interval is always from the beginning of the P wave to the beginning of the QRS complex, whether the QRS complex begins with a Q going down or with an R going up. That is your PR interval. The PR interval represents the time between atrial depolarization to the beginning of ventricular depolarization. In other words, it's the time of transmission from the SA node to the AV node. So a normal PR interval is between 3 to 5 little boxes. And remember that 5 little boxes is one big box. So it's between 3 to 5 little boxes, or from 0.12 seconds to 0.2 seconds. So this is a normal PR interval, and it is worth memorizing these values. All right, next one we're going to talk about is the QRS interval, or more commonly known as the QRS complex. So the QRS interval contains everything from the beginning of the Q wave here to the end of the S wave over here. And do remember that the QRS interval doesn't always have a Q wave. Sometimes it simply has an RS complex, like here. You would still measure it in a similar fashion. Or sometimes there's an RS R prime pattern, like here, and you would still measure it in a similar fashion. So that is the QRS complex. As we already know, this represents ventricular depolarization. And a normal QRS complex is between 1 to 3 little boxes. In other words, from 0.4 to 0.12 seconds. All right, the next one we're going to talk about is the ST segment. There's not much to measure with the ST segment right now. It is important for several reasons. The ST segment can be elevated or depressed in certain pathologies, such as ischemias or structural or conduction abnormalities of the heart. Because of this reason, it's always important to look at the ST segment. The ST segment begins where the S is ending and ends where the T starts to come up. So between the S wave and the T wave, that's your ST segment. And remember, you want to keep an eye on it to see if it's elevated or depressed. And this is the time before repolarization, ventricular repolarization happens. Finally, we're going to be talking about the QT interval. The QT interval starts where the QRS complex begins and ends when the T wave ends. So everywhere from QT. But again, keep in mind that not every QRS complex starts with a Q. Sometimes it does start with an R. Again, same thing, just measure from the R to the T. A normal QRS complex is difficult to measure because you have to correct for the rate of the EKG, and then get something called a corrected QT interval, with normal being less than 470 milliseconds. But there is a way to eyeball it and kind of guess whether the QT interval is within normal limits or not, just looking at the EKG, and that is to check if the QT interval is less than 1/2 of the RR interval. We'll see more of this in the following slides when we get some practice. Alright, so let's get some practice in. If you want to pause and give this a try, go ahead, but I'm going to dive right into it. The PR interval is what we want to look at first in this EKG strip. Remember that the PR interval is everything from the beginning of the P wave to the beginning of the QRS complex. And you can see over here, it's approximately about 4 little boxes. So in this example, it's about 4 little boxes. And remember that normal is anywhere from 3 to 5 little boxes. So we're within the normal range. So we would say that this EKG strip has a normal PR interval. You can go ahead and calculate the duration out too. So if you have 4 little boxes and each little box is 0.04 seconds, this would end up being is equal to about 0.16 seconds. Now let's look at the QRS complex, or the QRS interval. Remember that the QRS complex contains everything from the beginning of the QRS complex to the end of the QRS complex. And if you look closely here, this is just below 3 boxes. I would say this is about 2 boxes long. So here it's about 2 little boxes long, which is equal to 0.08 seconds. And again, this is normal. You may recall from one of our previous videos, we discussed what happens when we have a widened QRS complex. And we talked a little bit about how this may represent a rhythm of a ventricular origin, because we don't get that synchronized contraction of both ventricles we would otherwise get with a AV node conduction or a SA node conduction. You'll see more of this as we go forward with our modules. Okay, next one is the ST segment. And remember, we want to see if the ST segment is elevated or depressed or looks funny in any way. So when I say elevated or depressed, what am I actually comparing it to? Because we need some kind of baseline to compare the ST segment to. Well, we want to compare it to the TP interval, the TP interval being here. This is our baseline, and we want to see how the ST segment compares to that. Is it elevated compared to the TP interval, or is it depressed compared to the TP interval? In this case, there's no elevation or depression of the ST segment, so we're going to say it's normal. And finally, we want to look at the QT interval. Remember that the QT interval is from the beginning of the QRS complex here to the end of the T wave, just about here. In this case, it's about 2 big boxes plus 1 little box, if you look closely right here, which is equal to about 0.44 seconds. So QT interval here is about 0.44 seconds. Remember that to determine whether this is normal or not, you do have to use a calculator, or if you have the equation memorized, use the equation to determine the corrected QT interval. However, it is important to know how to just eyeball this and kind of gauge whether this is normal or not. Remember, we want to see if the QT interval is less than 1/2 of the RR interval. So the RR interval here is from, in this EKG strip, is from here to here, and we're comparing this portion right here to this portion right here. And I would argue that yes, it is less than 1/2. So I would say this is likely a normal QT interval. Okay, pause the video, give this one a shot. First thing we want to look at is the PR interval. So the PR interval. To look at the PR interval, we have to look for the P wave. It's going to start in the beginning of the P wave and end where the QRS complex begins. So you can see it here. And actually over here, it's more than 1 big box. It's more than 5 little boxes. It's about 7 little boxes. Or if you did the math out, that comes out as 0.28 seconds. This is abnormal because it's greater than our normal values of 3 to 5 little boxes. What could this mean? So this could mean there's some kind of issue with conduction from the SA node to the AV node. This EKG strip actually shows what's called a first degree heart block. We'll talk more about heart blocks in our conduction abnormality module, but here you can see that the PR interval helped us diagnose a first degree heart block. Alright, let's look at the QRS complex now. The QRS complex contains everything from the beginning of the Q wave to the end of the S wave. And if you look closely, you can see that this is just below 3 little boxes. So we would say this is normal. Next, we're going to look at the ST segment. Remember that the ST segment is from the end of the S wave to the beginning of the T wave. Here there's actually a smaller ST segment because you do see pretty prominent T waves here. You might think that the ST segment looks elevated because of the T wave pulling it up, but do remember that the ST segment ends before the T wave begins. So it's really this segment right here. We're comparing it to the TP interval. There's really no elevation or depression in this EKG of the ST segment. So we're going to say this is normal. Finally, we want to look at the QT interval. This is from the beginning of the QRS complex to the end of the T wave right here. And in this case, it's about 9 little boxes. So 9 times 0.4, which is equal to about 0.36 seconds. If we tried to compare this to the RR interval here, we do notice it is significantly less than half. So the QT interval is less than 1/2 of the RR interval. Therefore, it's just about normal. Okay, pause the video and give this one a try. Alright, let's start with the PR interval. You'll notice that there aren't any P waves in this EKG strip, so we really cannot calculate the PR interval. What about the QRS complex? Well, we can look at any of these leads, but I think V1 has the most prominent QRS complexes, so it's easiest to calculate in there. And I'm going to look at this first one right here. Starts over here and then ends over here. I would say this is almost 4 to 5 little boxes. Let's go with 4 little boxes, which is abnormal, right? Because normal is between 1 to 3. So we would say this is a wide complex. Next, we want to look at the ST interval. And we want to look at the ST interval in every single lead. In this particular EKG paper, you'll notice that most of the ST segments are okay, except the ones in V1 all the way to V4, or even to V5. Notice how the ST segment in V1 is depressed compared to the TP interval. Same thing in V2, it's depressed here compared to the TP interval. You'll notice that in V3 as well as V4. And even a little bit in V5, just a tiny bit in V5. So we would say there's ST depression either in the precordial leads or just identify it from V1 to V5. Finally, we want to look at the QT interval. I think the best place to do this is in V6 where the T wave is prominent enough to see. If we eyeball it, we can definitely say this is less than 1/2 of our RR interval. And if you go ahead and calculate out the QT that's not corrected, you'll end up getting about 2 little boxes, which is about 0.4 seconds. So the QT not corrected is about 0.4 seconds. So let's think about what's going on here. We don't have any P waves, and then we have this regular rhythm with a wide complex going on. The wide complex can be a result of a number of things, such as heart blocks or ventricular abnormalities, or it can just be a rhythm that starts in the ventricle, as we discussed in a previous video. In this case, the reason we don't have any P waves is because we have a idioventricular rhythm that begins in one of the ventricles, resulting in dysynchronized contraction of both ventricles. And that's why the QRS complex is wide. We don't see any P waves because these complexes are not of a P wave origin. The SA node is not causing these QRS complexes or ventricular depolarization to occur. Finally, why do we see this ST depression in many of these precordial leads? Well, because these ventricles are not depolarizing at the same time, they're also not repolarizing at the same time. They're repolarizing a little bit apart from each other. This would result in EKG's changes consistent with repolarization abnormalities, and usually this means T-wave inversions, as you notice here, and ST depressions. So let's put that all together. We don't have PR intervals because we don't have P waves, again because this is a ventricular rhythm. Because it's a ventricular rhythm, our QRS complexes are prolonged. And because it's a ventricular rhythm, we have dyssynchrony of ventricular repolarization resulting in ST and T wave changes. This was a tough one, but a good one to practice everything we've learned so far. Alright, take a moment and try this one out. Okay, let's look at the PR interval. We'll be quicker on this one. I can see one PR interval right here. You'll notice it is less than 5 big boxes. So we'll say that the PR interval is normal. The QRS complex, if you look closely at it, is less than 3 little boxes. So we could say this is normal as well. I don't see any ST elevation or depression in this EKG strip. You will notice that the T waves are pretty wide and maybe even a little bit elevated, but there's no ST changes in this EKG paper. So we'll say normal ST intervals. Finally, we want to look at the QT interval. So that's going to be from the beginning of the Q wave to the end of the T wave. And here you'll notice it's a little bit greater than 3 big boxes. It's almost about 17 little boxes long, which is equal to 0.68 seconds. If we eyeball it, we'll notice that the QT interval is definitely greater than 1/2 of the RR interval. So this is actually a prolonged QT interval. There are many things that can prolong a QT interval, such as certain medications or congenital heart diseases. It is very important to identify because this leaves patients more susceptible to arrhythmias. Alright, good job. We went through a lot in this video. The takeaways for this video: so EKGs have several intervals, segments, and complexes that can give away information on cardiac conditions. Keep in mind what a normal is for PR intervals, for QRS complexes, QT intervals, and ST segments. We went through a lot in this video, and I hope you can start appreciating that we are beginning to put things together. We're going to continue to put more of these concepts together, eventually to a stage where you have a good fundamental understanding of EKGs and how to interpret them. Okay, see you in the next video.